Hey everybody, welcome to the CNC with Dave show. We've got a good show for you tonight. Tonight we have Mr. Ron Cleveland is going to be talking about his 3D printing, and I'm particularly excited because I don't really know much of anything about 3D printing. So I hope I'll be a whole lot smarter at the end of the hour here. So at least with 3D printing. So before I've got a few announcements I need to do, and before I do that, we'll get the panel introductions here. Javi, you want to start us off with the introductions?
Sure, be happy to, Dave. My name is Javier Unzueta with Javi's Woodshop. You can find me on YouTube, Facebook. Just follow my Hoarding to Boarding series. By the way, Dave, I'd like to publicly thank you very much for your help in setting up my new water-cooled spindle, getting the all the settings right. I really appreciate that. Thank you for having me.
You're very welcome, Javi. And I for those of you watching, I told Javi before the show, you don't have to thank me because all I did was turn mine on and reading what my parameters were. So it's not like it was any genius work by me. I just I know mine works and I know what it's set at, so I just kind of copied the settings. So glad you got it working though.
I appreciate it.
Next, we have Mr. Juan Lopez.
Hi, guys. Juan Lopez. You can find me here on YouTube, Instagram, and on Facebook under G-Code1 Design. Thanks for having me, Dave.
All right. Thanks for being here, Juan. Appreciate it. Next, we have Mr. Lindsay.
Good evening, everyone. My name is Mark Lindsay. You can find me here on YouTube, especially down in the comment section. I'm also most active over on Facebook in Too Many Groups to Count, and on Instagram and Twitter, and my website, marklindsaycnc.com. Thanks for having me, Dave.
All right, Marky, thanks for being here. And we'll get to Ron here in just a sec, but I got a couple of things I wanted to mention real quick. You know, we keep talking about the Nashville meetup. I still am working on trying to nail down a place. So far, everybody I've talked to, they want money. And it's hard to say because I don't know exactly how many people are going to show up, so it's hard, and they're all wanting their money now, so we may just end up just showing up and going to some kind of a pizza joint or something. I'll talk to a few of those and see who's big enough to handle an extra 20 to 30 people or whatever, because I don't know how many is going to show up. But anyway, the date will be September 30th. Just don't know exactly where yet, but I'll let you know that as soon as I come up with something. The other thing I want to talk about real quick is, Brian Gidney at Summers Woodworking is doing the Birdhouse Challenge. And I caught part of his, he had a little show on earlier tonight. Kind of a question answer thing about the challenge, and if I heard him right, he's going to extend the deadline because it didn't get started, I think, until June 13th, and he was going to end it at July 1st, and I think he's now going to extend the deadline to July 13th. So everybody will have a whole month to do that. So I hope everybody will try to take up that challenge and see what kind of birdhouse you can make with a CNC or maybe a 3D printer. Who knows? But anyway, I guess, and of course, next month, which is coming up pretty quick, from July 1st to, well, I guess it runs the whole month of July. We've got Whirligig Wars, Russ Clarity, and Simply Wooden Creations is going to be doing the Whirligig Wars. So that'll be fun too. I'm going to try to get an entry in for that, although I don't know if, I don't really have anything in my head to design for that, but maybe by the time it gets here, I'll think of something. But all right, that's all I had. We're going to turn it over to Mr. Cleveland, and I know I've got a bunch of questions for him. But Ron, if you would, go ahead and unmute yourself and tell folks who you are, where they can find you, and a little bit about how you got into 3D printing.
My name is Ron Cleveland. I've been in 3D printing for about 2 years, I suppose, and I've always been a tinkerer. And so it seemed like something I wanted to get into. So I jumped in with both feet, bought a 3D printer that wasn't terribly expensive, and just went to Thingiverse, which is a pretty popular website online that has literally millions of different things you can download and print. And haven't looked back until I decided I wanted to try a CNC as well, since it was basically the same X, Y, and Z type setup.
Okay, so you had your 3D printer before you built the CNC, or?
Yes, I did. I just built the CNC in the last year. I finished about 3 or 4 months ago with it. Started about a year ago. I think when you first released your plans last June, I believe. I got in on that right away, and it took me a couple months to get started, but then I finished by, I think, last February with the CNC machine.
Okay, and I believe, correct me if I'm wrong, but I believe we have some photos of your build on the forum.
Yes, you do.
Or is it on the?
It's on your.
It's either
website.
on the website.
Yeah, it's on your website. At least the last time I looked.
Okay, it's in. Yeah, photo gallery. Okay, yeah, that's where it's at, I think. So, anybody watching want to go check that out? You can go take a look at that. And so, what made you want to get into 3D printing? I mean, is it just there was something new, and you just wanted to?
Yeah, I've been a guy. I've been in computers for 40 years. I've always built my own computers, and that kind of has fallen wayside because computers nowadays don't need to be replaced that often. They last for a lot longer than they did when I first started. Things aren't changing near as fast.
Mm-hmm.
And so that wasn't keeping me very busy. So I saw this thing about 3D printers, and I was actually kind of a late starter because it really took off in about 2003 when I first started hearing a lot about it. And it wasn't until 2005 that I got into it. Or 15, I mean, sorry, 15. And so at that point, I had no objective on what I was going to make or anything. I just knew there was stuff I could make that, and it's kind of like a CNC machine. How many people have come to you and say, well, what can you make with that? You know, or can you do metal? You know, how many times have you been asked that question? And
more than I'd like to count.
Yes. And the same thing with the 3D printer. Well, what can you make with it? You know, and, you know, is it strong enough to use and things like that? You'd be surprised. You turn around and everywhere you look, really, there's stuff that you can make just like a CNC machine. Until you've made it, you don't realize everything you can really do with it. And so, you know, it's like, here's something that everybody will know what. That is a dust extractor adapter.
Oh, okay.
For different size hoses. And as you can see, I have several different variations of dust extractor adapters, basically. Now I only have a 2.5-inch dust deputy, but pretty much every tool I have that does dust extraction, I can make an adapter for. Now that doesn't pay for the machine, but it's a good use for it.
3D printers have always struck me as the type of machine that when you really have a need for it, it's excellent to have.
Yep.
But once that need is fulfilled, now what?
Well, there's always going to be another need.
Okay.
I mean, and there's CNC machines can do a lot, especially the metal one, the milling machines, can do, you know, more 3-dimensional stuff, you know, stuff like what I do with with the CNC or the 3D printers. You know, I'd be hard pressed. Let's try to pull this over here. I'd be hard pressed to make something like this, which is basically a control board for a Delta printer, and printing the box and display and the knob, everything.
Okay.
Is 3D printed on here.
Okay.
You know, so you couldn't really do that with a CNC machine. Unless it's maybe a milling machine or something. But you wouldn't do it in wood, that's for sure.
Yeah.
So, you know, I'll show you this. These, this is something I did not design, but Thingiverse Online is a very popular website for 3D printers and CNC, actually. There's a lot of CNC files there as well. This was printed like that, all in one piece.
Wow.
And as you can see, I did not have to do anything to assemble it, but as you can see, it does move by turning. It's basically a scissor jack.
It's pretty cool.
And it printed all the pivot points and everything, the threads, all of that.
Everything.
In one piece.
In one piece. You've probably seen the famous crescent wrench demo they used to use years ago. Very similar idea.
Oh, okay, yeah.
Where they actually print the worm gear for the crescent wrench in there all in one piece and it all works.
Wow.
This is very similar. Similar idea. Now, I'm not good enough to design something like that, but you have any questions? Anybody?
What do you have there? And
Well,
cost?
I'm sorry, what?
What do you have there, and how much does it cost? Those 3D you got right there.
I actually have two printers here.
Doesn't beat around the bush, does he?
You're going to be amazed by one. This one here is actually, I don't know if you guys can see it, but it's actually printing right now.
Cool.
And so they're not very noisy. But this one here was $6.99.
Wow.
And it has a metal cabinet. It comes fully enclosed. And the only thing I really added to it is the build plate that I use. I use glass. I use what's called borosilicate glass, or better, some people would know it as Corning glass. It's heat resistant. And I get these from a McMaster car. They're 9x6, and that's my build volume, by the way. I can build 9 inches by 6 inches by 6 inches on these machines. This machine back here is inside is virtually the same as this one. The guts are interchangeable. Cost me $150 on Craigslist.
Nice. And Ron, what do you use for to have it adhere to the glass?
Okay. This is a setup question, I think. This is what I use.
Nice.
Hey, we didn't ask what you use in your hair. We just want to know.
Right.
Oh.
All weather Aquanet, super hold, unscented.
Now, do you get your wife to purchase that, or?
No, I actually go. I'm not married, so I have to go buy it.
I'm thinking I'd look pretty silly walking into, Walgreens.
Well, they probably look at me a little strangely. Can you still see me? Yeah.
Yeah.
A little strangely, because I usually buy like 2 cans at a time, and so they must think my hair needs a lot of hold. I don't know, but
I wonder what excuse I'd have to go in there.
Yeah.
Yeah, they really look at you weird.
You glue the cap to your head, maybe. The reason why I use Aquanet is, believe it or not, there's vinyl in Aquanet.
For some reason, that does not surprise me.
That's why it probably has such a good hold. But it also works perfect for adhering plastic, that vinyl, adhering plastic to the glass. And it just works. It's cheap. It's $2 a can. And it takes me 3 months to go through a can of it. I mean.
Do you mostly work with ABS or PLA or?
Actually, there's multiple. My paying stuff that I've done, that I do for work and stuff, I use ABS mostly because it's very strong. PLA I use more for the action figure stuff, like the.
And if you would, Ron, for
Darth Vader's.
Ron, if you would, for our viewers, will you explain what PLA is and what ABS is?
Okay. I can't really tell you what the actual chemical names are. PLA is the base plastic that almost every printer will use. It extrudes at about 200 degrees centigrade, and you don't necessarily need a heated build plate. The next one up would be ABS. ABS extrudes at around I do about 230 degrees centigrade, and I have to run my build plate at 105 degrees centigrade. That's one thing you learn quickly on 3D printers is everything's in metric. Probably because the machines come from China. But
okay. That's a question we got here. Random Audio Guy wants to know that are those heated bed 3D printers?
They are. Both of them use the same build plate. Both of them are heated. And both cabinets are fully enclosed. That's important for ABS because you want that chamber to stay as warm as you can possibly get it during the print process. To get ABS, especially PLA, not so much. ABS, you need it to sit flat and lay flat on that build plate. Otherwise, it has a tendency to warp and edges lift up and messes up the print.
Okay.
Now there are other filaments. There's PETG. PETG is what your water bottle is made out of, and it's actually becoming the new hot plastic, I guess, or filament for everybody. It's been around for a few years now, and you can do stuff like this. Well, see this, but this is one layer, but I don't know if you can see that. It's totally flexible and almost transparent.
That's pretty cool.
And
it almost looks like it's foam or something.
Yeah, it actually, I don't know if you can see, but it's actually hollow.
Oh, nice. Okay.
Have you ever worked with any wood filaments?
I have not. I have not done nylon or any of the wood filaments. Now, saying wood is still PLA.
Right.
They just add some wood fibers, so to speak, to it. But it still only has the strength of PLA. It'll never have the strength that ABS does. Nylon would be further up on the chart as far as strength past ABS, but that usually requires at least 260 degrees centigrade to print. And that's right on the edge of what my printers will do. See, I got one out just so you can see. This is how filament comes. It's this is HIPS, another type of plastic actually that's in the ABS range of strength and stuff. PETG, ABS, and HIPS are all real close to each other in strength. And these come in 1 kilogram or 2.2 pound reels like this. They're about $20 to $22, depending on what you do. Get PETG is a little bit more expensive. I have my favorite types. There's a lot of people make filament nowadays. I usually get mine from Amazon, and You tend to stick with the filaments that I know work well for me, because things can change. If a filament is from manufacturer to manufacturer, temperatures and stuff can change, as well as even color. Variations in color can cause you to have to print in slightly different temperatures as well.
There are some machines that I've seen that are completely open. Do you recommend putting an enclosure on all of those?
If you're going to do ABS, yes. PLA, no, you don't have to worry about it. But ABS, yeah, the more you can enclose that heat in the build chamber, the better results you're going to have.
What
now?
Sorry, go ahead.
I want to ask a question real quick, because you mentioned that the spool the material is about $22. And I'm trying to wrap my head around how long that spool would last on different things. So pick something that you've made, and then for example, okay, that right there, how many of those would you get out of a spool if you started with a brand new spool?
Probably about 15 of them.
Okay, wow, so you get a good bang for your buck then.
Yes. It actually, when I first got it, I was like, how many things am I going to be able to print before I run out, kind of thing, you know? Now, when I print these, I do run them both machines at the same time, because they do take 4 hours or so to print, and I just batch it out. I just, I'll have a spool on each machine, and they're both doing the same thing, and I can do, like 8 of these a day with both machines total. And I usually do about 10 at a time when I do print them.
Okay, now when you're running something like that, what happens if the spool runs out? I mean,
you pretty much ruin your print.
Okay.
So you try to.
So then my next question is, if you get ready to do a job and you don't have enough on your spool to complete that job, do you just have to take that spool off and save it for something smaller?
Yep, exactly. Yeah, that's exactly what you need to do. Is you print something smaller, and stuff. And when I say smaller, you can get actually downright quite small. Something as small as that.
Oh, okay.
Now, on some CNC related stuff, as far as machining and whatnot, some of the software tells you how long something runs, or that predicts the run.
Right.
Is there a way to predict how much plastic you are going to be using?
There is. I mean, I use a program called Simplify 3D. It's not a free thing. The process of doing a print, I'll go there and then I'll explain how it determines how much time and how much filament it's going to take. I use Fusion 360 to design my things that I print for work or whatever, and I design it and I save that out as an STL, and then I take that STL and load it into a program called Simplify 3D. Now, what that does is slices, in other words, builds the layer, one layer at a time, of the object you're going to print. So that's how a 3D printer works. It lays down a layer, then builds another one on top of that, and just keeps going round and round until it gets through the top. Now, in that program, you determine your temperatures, your feed, and even your speed. The other thing you have to worry about on 3D printers is overhang. In other words, if you have an object that sticks out, it can't just build in midair. Gravity is going to pull that filament to the down. So you have to actually, the program actually allows you to customize supports, which are little pieces of plastic that just break away after it's done printing, but it's enough to hold it up and leave it so it's not building in midair.
Cool.
And when you're done and you're saving your STL as a print file, basically, it actually estimates the time it will take to print that object. Are
those times fairly accurate?
Yeah, they're a little bit. It doesn't it takes a while. Say when my build plate has to get up to 105 degrees, that can take 10 minutes. So it doesn't take that into account. But if you subtract when it actually starts to print to where it finishes, it's relatively close. I just have to add a little bit for everything to warm up before it actually starts.
Yeah. Well, I know even when I'm running the CNC, and you guys probably do the same thing. If I do the simulation in VCar Pro, and I look to see what it says the time should be, and then sometimes I'll do it on Mach 3, but I always pad it and go, yeah, on a good day it might go that fast.
It's never accurate.
It takes longer than what it says, unless you really get it dialed in.
I was wondering more about the material usage.
As
far as, if it estimates it actually pretty close, or,
yes, it'll tell you how much material is supposed to be. I mean, if you keep track, which I don't, of how much you've printed on every print, and just keep adding it up, you would be able to determine if you had enough on the reel at the end to do that last thing.
Cool.
It's accurate enough to be able to do that.
That's cool.
Ron, is there any way to weld 2 pieces and re-spool one or something?
I think it probably would get stuck. The weak point of 3D printers is the extruder. And any bump or anything like that might make it hesitate, well, it potentially could cause a clog. And if you get a clog, sometimes it's easy to clear. Sometimes you have to take the entire extruder apart to actually and heat everything up, with a torch, and just I use or guitar string to run it through the 0.4 millimeter nozzle to clear it out, and so it's kind of a process and something I try to avoid at all cost.
That was another question I had. That you use 0.4 millimeter is that the standard size?
Yeah, you'll see almost every commercial 3D printer out there comes with a 0.4. You can get them from 0.1, 2, 3, 4, up to 6, and even actually a thing called Volcano with some extruders that even do bigger. So bigger, just extruding bigger lines of plastic, essentially. Of course,
so the one you have back there is actually a 0.4, or
it is a 0.4, but the software allows you to rein that down. So I can do a 0.1, a 0.2, or a 0.3.
And for you inch guys, 0.4 millimeter is right about a 64th or about 15 thousandths.
Right.
So that's
like
pretty small.
Like this was printed at 0.3. You can see layer lines on there, but the bigger the line you put in there, the faster your print goes. I probably printed this at 0.2. Now you can see if it focuses, you don't see the layer lines near as much on that.
And you were saying earlier that you can do 0.1, correct?
And you can do 0.1, yes.
And I checked that. That's 4 thousandths.
And you can do, when you get down to that point, you're doing some pretty detailed work, very minute type stuff. Let me see if there's anything I would do that at. Possibly these. Okay, I got a friend that does model railroad layouts and stuff. Very cool stuff. He asked me to make him some double hung windows. So I designed these on Fusion 360. I don't know how well you can see, but these were printed at like 0.1.
That is cool.
I have.
I'm assuming the smaller you go, you're adding cycle time or length of.
Right. Well, and these don't
print.
take as long to print. Like this, he wanted an industrial looking window. So I designed that up. I even gave him a little clear
Oh, cool.
thing to put behind it to make it look like it had frosted glass. Let's see if I could have any pictures I could show you. No, not there. That's not what I want.
Just letting you know the questions are piling up here.
Go ahead. Go ahead with them. I'll answer it while I do this.
Okay. First of all, let's see. Go back up here. Todd HCNC wants to know, is there any smell when you're melting that filament? And what do you do about vapors like for ABS?
ABS has a little bit of a smell, but not. I don't notice it too much. And it also is brand. I mean, you can have different brands of filament. I use what's called eSun, and I do not notice a smell from it too much. PLA
he hadn't
really
passed
does
out
not
yet,
have,
and he's got it running behind him there.
right. That I'm running ABS right there now, and believe me, I'm 10 feet from the central air unit here and stuff. It's not. There's no. The hairspray probably has a little bit more smell to it than the ABS does. But I was going to show you if I can get to it. Share here.
Okay. Mickey Sawyer wants to know, does your software calculate feeds and speeds like it does on a CNC or plasma cutter?
It does. I mean, you tell it how fast you want it to print, and that didn't work, did it?
You have to hit, now you switch over to what it is you want to share.
Oh, I thought I had. Okay, there you go. Can you see that?
Yeah.
There we go. Got it.
Okay, see those double hung windows on that?
Mm-hmm.
Those are the windows I made for this guy.
Wow.
That's pretty neat.
This guy, this is probably cereal box cardboard that's this whole building is built out of. He likes to reuse stuff, but this is kind of work he does. And it is as realistic as you're going to get in a miniature of anything you've ever seen.
Wow.
Yeah, right down to the rust.
Yeah.
Yeah.
And yeah, he does 2 or 3 of these a year, and they're just quite literally amazing. And this is all done with paint and cardboard and stuff like that. He finally got tired of making his own windows, so he asked me to start printing them for him. But other than that, so that's stop sharing. What I do use those windows for. And yeah, okay, go ahead, Mark. Any more questions?
Oh, lots of them.
Go for it.
Grant Clark wanted to know, did you have to put that, did you have to assemble either of those 3D printers, or did they come assembled?
Actually, no. Did not. The extruder carriage was unbolted. You had to put 2 screws in to hold that down. But other than that, no, these were fully assembled.
So basically almost plug and play.
Exactly. It was literally 2 screws to the. Now I have modified mine a little bit. I went. They don't come with the glass build plate. I've modified mine to work with glass. They come with what they call kind of a plastic label-like thing that sits on the build plate that it builds on. But I found that hard to scrape off. Plus, you're throwing the level of your build plate off when you do that.
Okay.
So I got away from that fairly quickly, and have a lot less hassle with. I've also modified it. You know, you can see the spool at the top there turning a little bit as it pulls filament down. It doesn't come that way. You know, that's all my contraption up there holding those spools. It has little holders on the back. That's what actually this was originally. It on the back of the machine, and the spool would sit on here and then feed from the back. I just wanted something that I could change quicker and easier. So I went to the system I have there now.
Okay. Okay. Got 2 related, so I'm going to kind of daisy chain them off of one another. Mickey Sawyer wants to know about how much heat some of those materials can take after they've cured or whatever.
Okay.
That's part one.
PLA takes, you do not want to leave your PLA printed object in your car in the summertime. It will warp. It will shrink. It will melt. So, I mean, it won't melt like a candle, but it will melt. ABS, which is almost everything, there's probably ABS stuff in your car, will take the heat just fine.
Okay.
It takes, you know, I don't know, I've shown this before. My CNC machine, instead of doing the HDPE like Dave has on his, for his adapters between the motor and the supports, I designed and 3D printed these.
Okay, you're holding them way off to the side.
Okay, here we go.
There we go. Yeah. Oh, okay.
And this is ABS. Now these aren't going to melt much before 500 degrees.
Okay.
That's cool.
Okay.
So, and it's plenty durable. That's one thing you do learn to design. When you design something and print it, you want to print it so the layers are on the strength of the thing. You don't want it being able to pull apart. In other words, if you have, you don't want to pull against the layers. You want to go tangentially away from it, if you know what I mean.
Yeah. Yes, I do. Okay, got it.
If I could say that word.
Yeah.
But I've actually printed a lot of stuff for my CNC with the 3D printers. I actually built my own control box using an old little computer cube that I had built on a computer years ago. And let's see if I can show that.
Okay, well, while you're doing that, I can ask you a real quick one here from Bob Heltebridle. He wants to know if you have a 3D scanner to scan in objects.
I do not. This is 3D scanning is an art as well as expensive. Yeah, there are cheaper methods of doing it, but they're not very effective. You really want good 3D scans, you got to spend significant amount of money, a few $1,000s, 1,000 up at least. And so I have not found a need to do that yet. So far, I've been using Fusion 360 and have been able to design what I needed. I'm good at drawing circles and squares.
Yeah.
And Fusion 360, I'm not so good at doing organic type stuff, which Fusion will do as well. But now this, if you can see that picture there, that's the back of my control box for my CNC. And so I 3D printed it, the black area there.
Okay. Great.
I like that.
Aircraft connectors and the whole thing.
Yep. Got to turn off the share.
Okay, you just gave me one thing I could use a 3D printer for, Ron.
What's that?
making that control panel.
Yes,
on the back
that's
there.
that's just it. You can make control panels and things that you wouldn't necessarily make out of wood. You
could even incorporate raised lettering if you wanted to, but you can come back and paint later, correct?
Yeah, exactly. That's what I was showing earlier with this thing.
Okay. Okay.
If you can see inside there, you'll see a blue snake-like thing. That's a drag chain. That particular cable is hooked to the Y thing, so it's moving back and forth. And that cable that hooks to it tends to break. So I 3D printed a drag chain.
Yep.
Nice.
For it.
Ron, that last model that you were holding up, the letters, the raised letters.
Yeah.
Is that a different color plastic, or is that
that actually was printed separately and glued on?
Ah, got it.
ABS, or most of the plastics, react really well with super glue.
Okay. Well, you can also get ABS cement down in the plumbing section at a hardware store, can't you?
Yeah, you could. ABS is very susceptible also to acetone.
Okay. Yeah.
And
I have a question on that.
Acetone will melt ABS.
Okay.
And it actually, that's another method of, instead of hairspray, another method some people use is called a ABS slurry. And what they do is they take some ABS, and anybody who does 3D printers has boxes full of 3D printed stuff that are either failures or didn't get used or just test subjects. Believe me, I have a couple boxes full. And you just put some ABS in there, you stick in your plastic part in there, it just melts it into a goo. And then you can paint that goo on the glass, and then the thing can stick to it.
Okay.
So that's another method. Some people also use blue painter's tape, kind of a method of Mark's, similar to Mark's idea for CNC, where you use blue painter's tape, and you can, but if you put that on there, put alcohol, wipe it down with alcohol first, Avi.
Yep.
Then it'll stick.
I'm a painter. I don't know how to use this stuff.
On a related note with the acetone, Jim Bashirs wants to know, what do you think of putting prints in acetone vapor to smooth them out?
It works. It's highly dangerous. You're actually always do it outdoors. You're heating the acetone up to about its boiling point. I'm not sure what temperature that is, but so the vapors lift and surround your ABS object, and it smooths the ABS out. But like I said, you're dealing with acetone vapors, which are highly flammable. I mean, this stuff will burn you in a heartbeat. And so it's not for the faint of heart to do. Always do it outdoors if you do it.
132.8 degrees Fahrenheit. Boiling point acetone.
Yeah, it's my son knows, has a couple friends that were doing some finishing in their basement on the wood floor with acetone. They both ended up in the burn ward.
Yeah.
This stuff is very dangerous.
You got to be careful with acetone. And a little bit of trivia for those of you that don't know, nail polish remover is acetone.
Yes.
Let's see.
Yes, it does have that nice fragrant smell.
Yes, it does. Let's see. David Kohler wants to know, are your failures recyclable?
I wish they were. Unfortunately, nobody's offered a service for such things. And there's always been talk about somebody building a machine that would grind down the plastic, turn it into pellets, and then you can extrude your own new filament out of those old parts. But nobody's actually came out with a machine yet that is reasonably priced that will actually do it, because the filament has to be perfect. This filament is 1.75 millimeters diameter, and you can't have any variations in that thickness or it will stick in your extruder.
Okay, we're getting real close to the end. Here, Mickey Swoyer and Todd H. CNC both have questions on the controllers. Todd H. CNC wants to know what kind of controller is on the printer, and Mickey Swoyer wants to know, could you plug that printer into your CNC controller? Does it use Mach 3 or is it completely different software?
It is basically standalone. Unlike a CNC machine, I use it's all standalone. There's an SD card slot in these. You just load the print file on the SD card, drop it into the slot, and then select it through the menu on the front of it to select your print. And it just reads the instructions off the SD card and goes from there. So it's not really hooked to a computer at all. It can be. You can set it up through a USB and run it from a computer to the 3D printer, but that adds another layer of possibility of something going wrong if something happens on the computer. So I don't usually do that.
Okay. Okay. Mickey Sawyer also wants to know, is there an acrylic type of material?
Not that I'm aware of. There are, I mean, literally, come here, dozens of different materials, from flexible materials. In other words, I mean, you can literally make a fan belt out of some of the filaments that are available, but they're more specialized and they take higher temperatures usually. But nothing in the acrylic range that I'm aware of.
Okay. Now, what was the transparent material that you were showing on those double hung windows that you printed for?
Well, that was PETG, but you can also get it. PLA makes it transparent as well as ABS. Most of the plastics actually have a transparent color, if you can call lack of color color. Sure. But they can be. I mean, you can get a whole rainbow of colors. By the way, you know, pretty much any color you can think of is available.
Okay. Okay.
Okay, Ron, we've got about 15 minutes left.
Okay.
And I want to ask you questions, kind of the same type questions I get all the time. If I'm a guy looking to get into 3D printing, tips do you have for me? How much am I going to have to spend to get started, to get a fairly decent 3D printer, and what kind of stuff do I need to look out for?
There's two on 3D printers. There's two ways to go. Not unlike CNC, you can start with a pre-built box that, like I have here, and they're going to cost a little bit more, and they're fairly easy to come by, like on Amazon and such. And then there are the kits, which are usually cheaper, and but you're going to build it from the ground up. You're going to put every nut, bolt, and screw in them. Those are usually, there's several types of printers. Some of you may have seen the Nozzle type printer, or Delta, which is kind of a tower looking thing with arms on it, and that move the extruder around. It doesn't, like on mine, the build plate moves up and down. On that one, the build plate stays still. The extruders move the X, Y, and Z all from one point, from three tower that it attached to. Those almost always are kits, and they do a very good job, especially if you're going to stick with just PLA. Now, it depends on what plastic you're going to use. Do you want to do ABS or nylon? Then you're going to need something that's enclosed. If you're going to stick with PLA and even PETG, you don't need to be enclosed necessarily. The other thing to look for is, does it have a heated build plate? If it doesn't have a heated build plate, you're only going to be able to do PLA for the most part. So you can get a budget kit, like Model Price and stuff offers pre-built systems for $200 to $300, but none of them are enclosed. They're all open air machines. So you're kind of limited on your on the types of plastics. Now, there are a lot of guys out there. I'm just as many 3D printing groups on Facebook as I am CNC, and have come up with their own enclosures to go around these things that will do the same job. But you're starting at 200, and the sky's the limit there from there on up. But if you're just starting out and you want to make something that's a little bit smaller, you know, you don't need anything that makes a really big thing, like over 4 inches or something like that, then those $200 ones are just fine to start with.
So,
okay, the ones you have back there behind you, what's the capacity of those? What's the largest size object you could make?
On both of them, they're, like I said, inside they're identical. So I can do 6 by 9 inches by 6 inches tall. Some of the newer ones I'm seeing, I'm kind of watching, have come out here this year, will do 12 by 12 by 12. inches minimum. I think one does 12 by 12 by 15, and you can buy that thing for $400. But it is not enclosed. You'd have to hack together a system to enclose it if you want to do ABS.
Mm-hmm.
If someone were to want to build, I know it wouldn't make any sense, but let's say they wanted to, they have a CNC machine now and they just want to swap their head for an extruder head. Obviously, they'd be limited to PLA without a heating, or what would be some of the downfalls, or would that just not be recommended at all, aside from having to have an extremely level base?
Well, if I'm not mistaken, doesn't VCarve have 3D printing capability kind of built into it a little bit?
You know, I don't know.
I thought I saw it in there, but I can't. Obviously, I haven't used it. I don't think so. In theory, it is possible, but you'd probably spend as much trying to make that work,
right,
as it would be just to buy an actual 3D printer.
Yeah,
you know, it's possible, but is it worth it? Is the kind of the thing there.
Yeah, and the precision on those machines. I have a rotary engraver that is miles more precise than my CNC router, and the CNC router is pretty precise. Are these really? I mean, I imagine they're down to the thousandths of an inch, clearly.
Right. Yeah. They. Well, when you're talking about the layer lines that I said, you can get down to 0.1 millimeters. You can get some pretty fine detail out of them. But you can also, the CNC in a different way. I think because you're not moving as much mass and in there with the print head, the extruder, and it's moving a shorter distance and everything. It would inherently be a little bit more, detail. But on the same token, there's some of the bigger 3D printers now are offering CNC adapters. And they're actually going the other way, where they're turning their 3D printer into CNC machines. Some of those bigger build volume machines. I don't know how successful they have been. I think anytime you try to make one thing do multiple things, it's never going to do all of them really good. You build a machine you build a machine for what it's intended for.
Yep.
Yeah. Ron, I had a question for you too. You mentioned that you're in several 3D printing groups. From your experience chatting in these different groups and stuff like that, of all the people that have 3D printers, what is there any one thing that stands out as what they're using them for, or is it just kind of all over the place?
Well, I'd have to say, first off, I'm probably on the upper edge on the age range on people using 3D printers. So what I print might be a little bit different than what dads are printing for their kids and things like that. So yeah, I'd say most of the guys are printing not necessarily tool related items, but more like more stuff like this. But I actually, you probably have seen things like these on Rockler, where you get the center of your board. You put a pencil
center
in it.
fingers, yeah.
Yeah, center fingers. I just 3D print them.
Okay.
I have this thing. You want to do curves on your corners and stuff? That's what that's for.
Yeah, well, radius gauge kind of.
Radius gauge. Something it doesn't cost a lot, like at a Rockler store or whatever, but probably cost me even quite a bit less to just print one myself. I have this little thing. It's just a little driver holder. This one I did design myself, by the way.
Okay.
But yeah, there's multiple things. I do a lot of soldering and stuff too. I do electronics and stuff. So I have a little holder that can hold the wires.
Yeah, that's very handy.
Fair warning, I have more questions coming in.
Okay. Go ahead.
That was just fair warning. We've had about 6 people notice that all of a sudden the lights went out in the unit right behind you that was running a print. They want to know, is it finished, and can you show what you were making?
Yes, I can. Just a second here. Give me a minute.
I kind of figured Ron had it done.
The build plate is a little warm. I have to, since I'm not putting it in the freezer, I'm not waiting for it to pop off. I'm going to force it off here. And what this is a tool, actually. A little sander. You wrap the sandpaper around here, and then this little wedge goes in here to hold the sandpaper in place. And you can get into those tight areas.
Oh, jeez.
Now you'd use, what did I do with it? You know, had some sandpaper here a minute ago, but I don't know where it went.
You started that print just right when we got ready to start the show?
Yeah, just before we started.
Okay.
And you can do it either way. If you got something like this here you want to get into, or you can go on your point, just wrap your sandpaper around the point there, and this little wedge holds it in place so it won't slip out, and you can get into those detail areas on your signs that you make.
Okay. Okay.
And you can make, now I saw a YouTube video on this the other day, actually. It's not an original idea. But you can, if you're good with Fusion, you can go in and make any shape you want. So it matches the shape of slot or whatever on your sign or whatever to be able to sand it.
Very cool.
Well, Ron, I have to admit that after listening to you the past hour and seeing the different things that you can make, it kind of gets my wheels turning. You know, because I really didn't know anything about 3D printers, but now that I've seen some of the samples and you know, stuff you showed, like I said, it kind of gets my wheels spinning a little bit, thinking about stuff that I could use to make for myself.
Right. Well, like this is a tool holder, you know, screwdriver holder.
Yeah, I was thinking of making some GoPro.
That's a nice color too.
I was thinking of making some GoPro
you'd appreciate
holders.
that. It's like, you know, this one too is.
Well, I have to buy a lot of those spools.
One of my other hobbies that I've been neglecting of late is RC cars, and they're electric, and I do the what they call carpet racing. And
I was going to ask you about that because it looks like way above your head.
That's an old car from the 80s. That's an antique, actually, up there that I had from the 80s. But the ones I have now are real low to the ground, and they're like road racing cars, and they race on carpet. And so I make parts for them too. And you know, since I do it, you know, like I can make fan covers, and those have cooling fans on them to keep the motors cool and stuff. You know, I make little fan covers for them. Let's see what else. I've made little holders to hold my remote controls, which you could do with wood too, but I didn't have wood at the time, CNC at the time I made these.
Have you ever made any GoPro or iPhone accessories or anything like that?
I have not. I made some mounts for cell phones and stuff, but I've never actually made one for a GoPro. And then there's this thing here. It's a little hand drill. As you can see, it has a.
Okay.
So you can actually get pretty detail with that thing. I mean, because it builds it like that, and it just works its way up.
Okay, we have two people asking, what is the brand and model of each of your machines back there?
Okay, the metal one is a QD Tech. Actually, highly recommend them as a company. They have been the most helpful company in the world. I made friends with them evidently on the forums because all of a sudden I got an email from them saying, if you need anything, just let us know. We'll send it to you. I said, well, I'd like to have this, this, and this. And 3 days later from China, I had it at no cost.
Wow.
But they are, customer-wise, they do their best. That one is $6.99 on Amazon right now, this machine here. The one behind me is a CTC that is heavily modified. I picked it up on Craigslist for 150 bucks and then spent another 200 bucks enclosing it and beefing up the build plate and a few other things. Otherwise, the internal parts, the board, the control board, the display, the extruders, all the major parts are interchangeable between the two machines. So they run the same software.
Now, Ron, since you got the other one for $6.99, and when you found that one for 150 bucks on Craigslist, were you apprehensive at all about, well, there might be something wrong with it, or were you confident that it was going to be a good buy and you'd be able to get it to run regardless?
At that point, I had so many extra parts from the first one that I'd gotten from the company, just as spares. I had enough to make, if there was something wrong with it, I had enough to fix it. So it was not that wasn't too much of an issue for me.
Yeah, but I mean, it worked okay.
Yeah. Mm-hmm. I knew what I was going to need to do to it to make it work equivalent to my first one, which is, like I said, all steel, fairly heavy machine. The more you can reduce the vibration, just like on your build plate and everything, the better your prints will come out. So you want something that's very firm.
Well, now, what kind of a linear motion do they have? Is that lead screw? Is that cable? Is that belt?
Actually, they both run belts.
They both run belts?
Okay. Yeah. Well, okay. Well, I should say in two directions. X and Y are belt driven. Z is a lead screw.
Okay.
I don't know if you can see it in the back there. You see it. If you can see the three.
Well, I can see, but I don't know what I'm looking at. So.
Right there.
Okay, now I see it. Now I got you. Yeah.
That's a lead screw that raises and lowers the build plate.
Okay.
So your Z. The X and Y are on carriages and are belt driven.
Kind of sounds to me like you're doing some of on a larger scale, I guess, than what my son-in-law is doing. He built him a small, cheap 3D printer, and he was into the RC cars, and I think he still is, but he's gotten more into drones now.
Right.
And he prints parts for both and stuff, and it's pretty cool what he comes up with. When he cracks a car, he can print the part most of the time.
Mm-hmm. And drones is a perfect example. Unfortunately, my dexterity or those kind of skills are long past my age. I just can't quite get the control right for that. That's why I'm not that fast on the RC cars either. Those young guys will blow me away. But yeah, for drones, 3D printers are very popular because there's a lot of stuff you can print for a drone. The whole chassis, everything can be printed with a 3D printer.
He does a lot of carbon fiber stuff with those.
Yeah, there is a carbon fiber filament that, but it's not. It's still PLA, but they can't put long. it has bits of carbon fiber in it. It's not like it has threads of carbon fiber in it. They just can't do that. So it's still, it might have a little bit more strength, but not as strong as true carbon fiber would be, because that thread is what holds it all together. And when you're melting the plastic, you can't melt, carbon fiber. And so it's going to just be little minuscule fibers, and they're not whole chains of thread.
Okay, cool. Do we have any other questions over there in the chat that we haven't got answered, Mark? Or
I think we finally got them all caught up, except for one, but it wasn't very specific, and I don't think the gentleman's still there. Jack Nepley wanted to know, how long does it take to print out the items you have? And there's so many items and so many different times.
Yeah, I mean, so you guys, see if I can get that down to where you can see it. This is just some of the stuff I've printed. Normally I don't keep it here. I have it in a box, but it varies depending on layer height and volume and how big the object is. I had a failed print here. I hate to throw it away because it's so pretty, but it's a Millennium Falcon.
Oh yeah, I see that. It's neat.
And as you can see, it got kind of cut off. The tail got kind of cut off on it, but it literally builds like that, and it just builds it back and forth. Something like this can take all night. I have had some that I think my longest print was 14 hours.
Now what you say that's a fail? What caused that to fail?
It ran out of room. If you measure this, that's like 6 inches.
Oh, ouch.
I forgot to figure that out before I started. And it's kind of like on a...
So could you have taken that same project, like you say it'll go 6 inches high?
Yeah.
Something that you want to print that's, say, 8 inches, can you just make 2 4-inch pieces if you design it that way?
Yeah. And in fact, you just gave me an idea. I may be able to fix this. I can actually take this original STL, cut it off at this point, and print just that part, and then glue it on.
Yeah,
I'm surprised
I would guess
not failed after all.
You can correct me if I'm wrong, but I would guess, since we're talking about plastic stuff, that you could design a lot of things where you could make things that, that like that was too tall, where you could make it in multiple pieces and put a hole in, or a couple of holes in one piece, and in the other piece put like those little pegs with where they kind of press in and then spread back out.
I'm going to show you something very, very weird, but practical, that I printed. How many of you have off your central air, a drain line going to a floor drain?
Oh yeah.
Well, we do too, but I wanted something more than just it sticking on the top of the floor, the pipe, the PVC just laying on top of the floor drain. So what I came up with was this, and I had to print it in 2 pieces. Share, where are you? There we go. Because it's bigger than my build plate. But I slotted it, I kind of dovetailed it, the 2 pieces.
Okay.
And so the top half dovetails into the bottom half. And as you can see right here, I made it so the PVC just slips in there. So that was, it's kind of a weird thing, but practical. But
where do you go buy one of those?
You don't. You can't.
Yeah.
So I have done what you've described, Dave. Now this is something I did design in Fusion as well. Good. So. Yeah,
I mean that's kind of what folks do, with their CNC. If they've got something that's too big, they either figure out how to tile it or index it through,
Right.
or just make it in multiple pieces and make it where it fits together.
Well, and also you can think of it as like a kit as well. It's like this. I'm going to show this one here. I wish I could get rid of that. This is a TARDIS I did.
TARDIS.
I sold about a half dozen of these at one Christmas a couple years ago, and it prints out as separate panels. So you got the 4 separate panels on the sides, the bottom, and the top is 2 pieces, and then the little light on the top is a couple pieces as well. So you're printing all these separate pieces, but it's all grooved and tabbed, so it all snaps together.
Now, you could put one of those little battery-operated LED lights inside of it, couldn't you?
Actually, it isn't designed for that. It even comes with a LED or a battery holder that you can put on the inside.
And those are about how tall, did you say?
I'd say 6 inches.
Relative because it's bigger on the inside.
Exactly.
Oh, I don't believe I set him up for that. Oh, my God. Oh, Russ, you do not deserve that.
Yes, I did, and I think you deserve it.
Oh, my God. Man, take away my straight man card.
There's something else I have printed. On the Craig tool I got, this thing. Mine didn't come with the dust shield or whatever you call it. So I 3D printed one of those.
Yeah. Yeah, I have a dust thing for my Craig, but it doesn't look anything like that. That looks a lot better, actually.
Yeah.
So there are some practical uses for it. Yeah, and you don't have to spend an arm and a leg to get one. I mean, you could get into one for $200-300 and have a perfectly acceptable 3D printer that does some small stuff. And it's now you don't use Mach 3 with 3D printers. You do use Fusion 360, or at least I do, to design things. But if you can design in CAD, it's a lot easier actually with a 3D printer than it is in CNC.
Yeah, well, I'm an old SolidWorks user, so
you should be able to do it just fine as long as you can export an STL.
Yeah. You really got the wheels turning tonight.
Yeah.
Well, I'm glad I showed you something.
Well, you said this. Here I go. You said this is on Amazon Prime right now.
It is. Yeah. QD Tech, QIDI.
And Dave, I think if you look on Amazon Prime, they also have cases of that Aquanet, so you don't have to go to the store and answer embarrassing questions.
But I have.
I'd try to buy that on Amazon Prime too.
Okay.
I can stay out of the store.
I have noticed it is more expensive on Amazon than it is at Walmart, though. You literally can buy a can of this stuff for $2 at Walmart. And it's usually a little bit more when you get it on Amazon Prime. But I'm as addicted to Amazon Prime as actually I'm in withdrawal. I have not received anything this week, which is quite unusual.
Just letting you know you're still sharing, Ron.
Oh, am I?
Yeah. My question about the TARDIS before Russ spiked the ball on me there was I can think of probably at least, I don't know, by name, at least 25 of my friends who would love to have a bunch of those as Christmas ornaments. Would you think those would be too big to hang off a tree? The size you made them?
What?
The little TARDIS.
The TARDIS? It would probably be a little large because it probably weighs a quarter of a pound.
Okay.
I can imagine you can scale it.
So you'd have to scale it down a little bit.
That is the thing, though. I use Simplify 3D in itself, costs $160. There are free options for oh, God, I can't think of that. Anyway, there are other options. There are free options, and but I use Simplify 3D to make the file for the 3D printer reads. And you can actually scale things up and down in that program as well, X, Y, and Z.
Cool.
You can also rotate it. You can. You usually want to when you build something on a 3D printer, you want it the most flat part of the object to be on the build plate.
Yeah.
And if there's any overhang, then you have to design what they call supports. And you can actually control, and that's just other little pieces of plastic that build up from the build plate to the part that overhangs to support it. And those usually are made so once it's done, they just snap off. You don't have to do any prep on them or anything. They kind of come to a point to where they touch the part that they're supporting, and then they just pop off.
Now, does the software figure out that part for you, or do you have to kind of plan?
No, well, you try to plan not to have as many overhangs as possible. If you know, but if you do, the software, you can tell it to automate or put the supports in there. Then you can go to manual mode and say, well, I don't need that many supports, and just start selectively removing a few, which is what I usually do.
Ron,
that iPad that we got, I believe, has a splicer and does put those supports on there too.
Mm-hmm.
That
well, Simplify 3D.
I don't know how well it works, but I seen that it had those features, that ViaCAD program.
Oh, okay.
ViaCAD? Okay.
And
Yeah,
Ron,
that's actually designing the supports in CAD, where the slicer will actually do the supports for you too. Actually, and make it even easier. Than you don't even have to design your own supports.
Right
Go
on.
ahead.
I understand the different. You can decide program the denseness of the build when you have a solid piece. How much is
right.
that correct?
Yes, you can. It's basically in the slider. It's a slider and you can go anywhere from 10 to 100%, and that's called infill. In other words, you have an object, you control how solid the insides of that object is. 100% obviously is as dense as it can be. And most of the time, if you don't need the strength to reduce build time, you slide that slider all the way down to like 20% or somewhere in that neighborhood. It's kind of like a honeycomb inside that just kind of supports the outer skin. And just depends on how strong you want the thing that you're working with to be. This thing here, the sanding block thing I printed, was 50%. I wanted to give it a little bit of strength, but I also want it to be a little bit flexible.
Mm-hmm.
Not a lot of flex in it, but there's enough.
Right.
Yeah. I see they're making fun of me over there in the chat, talking about somebody said, yeah, there'll be a brown truck show up at Dave's house next week. I'm gonna tell you right now, there's hardly a day goes by that brown truck don't pull up with something that I've ordered off of Amazon Prime.
Yeah. That's why I said they don't even bother looking up your address anymore. The trucks know them way by themselves.
Yeah, there's one guy that it's a UPS driver. I've only had him for a couple of weeks or so. I don't know, they switched routes or something. And apparently he's not a fan of big dogs because he won't get out of his truck. Because usually when they pull up, I'm out in the garage and Rocky always likes to lay right up by the street. There's a bush up there. He'll lay up there in the shade of that bush. And that guy, he'll come down the street, and as soon as he sees Rocky, he starts honking. You don't want to get out of the truck, but yeah, I'm a Amazon Prime addict. I'll tell you right now, I'm always getting something.
Now we're gonna have to start.
I think I know what one of my next big purchases is going to be. I can tell you that.
Anonymous or Amazon Anonymous Club.
Yeah. And I know I'm not the only one, so.
Yeah. Well, this is the sandpaper I was talking about. This, I don't know if you guys have seen this stuff before. It kind of has a vinyl kind of back on it. It works great with these sanding blocks. Yeah, and it's totally waterproof.
Yeah, I used to use something similar in the solid surface countertop industry. It was Mylar backed rather than paper or cloth.
Yeah. and it's super flexible. So you can wrap it around a small object to get into those detail areas that you need to.
And the stuff will wear forever.
Yeah. Well, you've seen, I think, who sells them? Woodcraft sells them and stuff. Those little pencil-like things that have sandpaper. I was seeing they wanted they had 6 of them. They wanted like $35 for them for a set. And it's like, no, I can 3D print one for about 25 cents. You know?
Wow.
Yeah.
Well, I tell you, Ron, I can't thank you enough for coming on tonight's show and showing us all the stuff you've made and explaining that. You seem like you're very knowledgeable on 3D printing, and you have opened my eyes, I think.
Well, I hope some others have. I mean, to me, it's a natural extension to CNCing. That's why I got the CNC machine as well. And for you, I showed this earlier, for you that want to see how close the 2 machines are, okay, there's the printers, there's the CNC.
Yeah.
So now, since my machines are enclosed, I don't really worry about dust getting into them. But so, knock the whole thing down. So they're just a few feet apart. And I'm usually a lot of times doing both at the same time. I'll be printing something on the 3D printers and cutting something on the CNC at the same time.
Yeah. Now, one thing that you just made me think of, you know, you said the little apparatus you have your spools hooked to, that's your own design. But I noticed that it's outside of that enclosure, right?
It is. There's a little hole in the back of the enclosure. It's kind of a rectangle right in the middle of it. I don't know.
Yeah.
That the filament
would
goes
you
through.
have to worry about when you're running the CNC, you know, particularly if you're cutting like MDF or something where that stuff, I know you got dust collection on your CNC, but do you have to worry about dust floating around and getting on that spool and contaminating?
I haven't so far. The dust collection actually works really well.
Okay.
I don't get a lot of, I get a little bit of dust on the CNC itself, but not very much. I'm actually pretty impressed with how well it does, even with when I milled the MDF top, you know, which probably is about as much dust as you're ever going to generate on a CNC. And I have like a 1.5 inch head thing that end mill that goes around there and does that. And it picks up the dust really well. I've been real impressed with, I'm sure a little bit escapes, but not enough that it seems to be getting, I get more regular dust on the 3D printers, I think, than I do CNC dust.
Okay. But, all right. All right. Well, cool. I know we're running over a little bit, folks, but I just didn't want to quit. We running a lot from Mr. Cleveland there, and I appreciate him very much coming on here. And
well, if anybody has any questions, just let me know.
I can see right now I'm probably going to have to create a category over in my forum about 3D printing. And,
well, if I can convert you, I might be able to convert a lot of people, huh?
Yeah.
What forum would that be?
The thing, I'm probably not as hard to convert as what you might think, because like I said, I already know how to do 3D modeling and SolidWorks and stuff like that. So drawing up the kinds of things that you've shown, that's not a problem for me. Now it might be for somebody who's, you know, hadn't been doing CAD all their life, but so that's not a big deal for me. And then it's just another way to make things that really, I mean, yeah, maybe some of them you could make out of wood or metal, but you know, why bother when you can just push the button and go do something else, and that thing just
exactly
and makes it. Just like the little the fan covers that you showed, and just like I said, I can start thinking of all kinds of little things now.
Well, just so you know, the little knobs. I saw somebody asking about the knobs on the end of their stepper motors that you can get from a Master car. I actually went to Master car myself, and as you know, they show a drawing of pretty much everything they have on there.
Yeah, you can even get the model a lot of times.
Yeah, well, that's exactly what I did. I downloaded the model that they had on their site, and I printed it, the knob.
Mm-hmm. Yeah, that's one reason why I've been a big fan of McMaster-Carr for years, because in my dealings with sheet metal that we used to do for a living, you could go to McMaster-Carr and find the model and download it and put it in your assembly and everything. It saves you a ton of time having to draw that stuff up. So
yeah, and a lot of their stuff that model is available.
Yeah. All right. Well, I guess that we're going to get out of here. Like I said, we're running a little bit over like we usually do. I want to thank you guys, Javi, Juan, Mark. Russ Meadows slipped in here. Thank you guys for being on the panel. Thank you, Ron, for a very good presentation showing us all your 3D printing stuff. And most of all, thanks to all you guys out there that have stuck around and watched tonight. We appreciate it. Hope you come back next week or whenever. And I guess that's going to do it. Anybody got anything else they want to say or want to bring up before we sign off here? I'll take that as a no. All right. Well, everybody have a good weekend, and we'll catch y'all later.
Good night.
Take care, y'all. Have a good weekend.
A good week.
Hit that thumbs up